How's it going, everybody? Today I wanted to show you guys how to install Samba. More specifically, how to set up a Samba server on any Linux machine you might be running. Now, if you're not sure what Samba is, it's a program that essentially allows for easy file sharing between a bunch of different machines. Any machine on the same network as a machine running a Samba Share can connect to it given the proper credentials, and that means all the machines on the network have the potential to have access to a shared file system where if any other machine makes changes in that file system, every other machine instantly has access to those changes. For this particular installation, I will be sharing a USB over the network, but you can just as easily do this with whatever internal storage media is present on the device running Samba. I recommend doing it on an external storage media, however, as it simply creates less points of failure. Now I'm going to go ahead and put the USB stick into my Windows device, just so I can verify that everything is working as expected and there's no kind of weirdness with the USB stick. Now that I have verified that there is in fact no weirdness, I'm going to go ahead and eject the USB stick. Now that the USB stick has been ejected, I'm going to remove it from my Windows machine and insert it into the machine running Linux. And once the USB stick has been physically connected to our Linux machine, we can verify that the operating system has detected it by running sudo blkid. Now, as for what this command returns, we should take note of a couple of things here. First, it's good that the label is the same as it was on our Windows machine. That's a good check. We should also check to make sure that the file system under type is the same as it was on our Windows machine. The last important piece of information to take note of here is where it is physically located in the Linux file system. Everything in Linux is a file, so the device location is also a file. In this case, it was given the file handle dev sdf1. So now that we know that our operating system has detected our device, we have to actually tell the operating system that we want to use the device, or mount it, as it is referred to in Linux. This might be confusing for new Linux users. If you're coming from a system like Mac or Windows, this process is taken care of automatically. You don't have to mount anything. Plug a device into your machine, it will automatically mount itself in the appropriate location. However, Linux is different. Linux requires you to tell it where you would like the file system that is present on the external device to be merged with the file system that is present on your internal device. Now we're going to take a trip on down to the root file system so I can show you a couple of common locations where these devices are usually mounted. The first one is the media directory. The other directory, which is the mount directory, both of these directories serve no real larger purpose other than to serve as a placeholder for mounting. For this tutorial, I will be using the mount directory. Inside of the mount directory, I will be creating a subdirectory that I'm going to name USB in all caps. This is going to be the physical location on the operating system where we're going to merge the two file systems, so to speak. Once that's done, we can get the device's location in the operating system once again using the sudo blkid command, and then we can actually mount our external device by running this command: sudo mount dev sdf1, and then the location we want it to be mounted, which is mount USB. And then just to verify that the mount was successful, I like to navigate to that directory and create a test file. And right now we're going to get some permission errors, but I will show you how to deal with those later. Now we're going to want to unmount it from our local file system so that it can be safely removed. And I actually made a mistake here that I decided to keep in the tutorial, so people could avoid making this same mistake. The operating system is telling me here that I cannot unmount the external device because it is busy, and it's busy because I'm in the directory where it is mounted. After I unmount the device and check the directory where it was, plug it back into my Windows machine, and lo and behold, the test file shows up. So now to address those permission errors we were having earlier. Linux and Windows use different file systems because Linux and Windows use different permission systems. Windows can use NTFS, FAT, FAT32, exFAT, and a few others. And Linux uses ext3, ext4, and a few others. Now Linux can read and write to any device that a Windows machine can read and write to. However, those devices might not enjoy the same robust permission system that a Linux/Unix machine can offer. If you're a Mac user, you'll probably be fine, as I understand Mac is Unix, as is Linux. They should use the same file system. But if you're a Windows user, you're going to need to convert whatever external device you were using originally to a file system that can enjoy the robust permission system that Linux has to offer. Alright, now for this situation, let's check our external device and see what kind of file system it's running. exFAT. exFAT is not a file system that takes to Linux permissions very well. But don't worry, we can very easily format this external device. In order to do that, we're going to need to unmount it first. After that, we're going to run this command with super user privileges in order to convert our file system to ext4. This is a file system that will take to Linux permissions very well. And if you do this conversion, you should get an output that looks something like this. After it's finished converting, we'll run the blkid command again, and wouldn't you know it, it's now ext4. Now that it's converted to a file system that Linux can understand a little bit better, you should be able to run any kind of change mod or change own or change group command that you need. Your individual implementation will vary, I'm sure, but no matter what implementation you have, you won't have any kind of weird issues with not being able to change the ownership or change the permissions of individual files inside of the USB device. Alright, now that we've got all of that sorted, we can finally get to the actual Samba installation. In order to do that, I want to show you guys what operating system I'm running here. I'm running Ubuntu 20.10. Fairly easy installation for this distribution, but it's not that much more complicated on any other given distribution. They're all going to start the same way, with an update to your package manager. Your Linux distribution has apt as its package manager. Sudo apt install Samba should work to download Samba to your system. However you installed Samba, you can verify that it was installed correctly by running where is Samba. If you get any other output other than what is shown here, your installation probably did not work correctly. Now I'm going to navigate back to the directory on my Linux machine where my external device was mounted, and I'm going to create a directory here called shared. Inside of that directory, I'm going to create a file called test. That's for later. This shared directory will serve as Samba's root directory, so to speak, for this device. Now, in order to actually share our directory, all we need to do is edit Samba's configuration file. I'm going to be doing that using Vim. You can do it with any text editor you would like. And the configuration file is located under etc samba. Once we're inside of the configuration file, just head on down to the bottom, as we don't want to actually change anything that's in this file, we just want to add something new to it. Now the few blocks above this should point out the kind of format that we need to write this in. In order to declare a new share, we have to put the name of whatever we want that share to be called inside of brackets. And it should change colors if you're using an IDE that supports that. Now there are a few different options that you can specify for your Samba share. I'm just going to be doing the bare minimum here, which is to tell Samba the path on the local file system to share, which in this case, the file path that we're giving it is actually located on the USB stick. Since we mounted it earlier, we can treat it as though it's a path that exists on the local file system. We also need to specify in this configuration that we want the directory that is being shared to be both browsable and writable to anyone that connects. We also want to make sure that we have all of our configurations at the same indentation as the rest of the configurations in this file, as if they're indented or spaced differently, it will cause errors. Now we need to run sudo service smbd restart. This command will restart the Samba server, and if it executes without error, that means that your configuration was correct. We then need to allow Samba through the firewall if you're running a firewall. To do that, we run sudo ufw allow Samba. Now we need to create credentials to actually log in and connect to our Samba Share. Samba uses separate credentials from the credentials for your Linux user. So your Samba user will have all the same permissions your Linux user does, but you'll need to create a new password for them. That can be done with this command right here. Now that we're back on the Windows machine, in order to connect to our new share, we're going to want to go to this PC, go to computer at the top left, and then click on map network drive. It doesn't really matter what letter you give it, I'm just going to choose A for fun. Using the example below, you're going to want to put in / and then either the IP address or the host name of the server hosting the Samba Share. And then the /share is just whatever the name of the share that you declared earlier in the Samba config was. So if you remember, we called it Samba example. So I'm just going to go to the config and grab that. So then once we've got something that looks fairly right, we've got the right IP, got the right name of the share, I'm going to go ahead and hit finish. Now if we've done everything right, this should prompt us to enter our credentials for this network drive. Now I'm going to be logging in with my Yalt user, but I'm going to be using my Samba password. As we can see, it was successful, and the test file is now on my Windows machine. If we go back to this PC, we'll notice that we now have a network location. Now I'm just going to verify that files created on my Windows machine will show up on the Linux machine. Now back on the Linux machine, we're going to navigate to the USB/shared directory, and we can see that the file that I created earlier is in fact there. So now I'm just going to run one final test. I'm going to create a file on the Linux machine again, verify that it was made, head back to the Windows machine, see that it showed up once again. Now I'm going to remove it on the Windows machine and verify that it is removed on the Linux machine. And there we go. We now have a connected file system. Thanks so much for watching, and if there are any questions, please leave them in the comments.